Here we compare two binary trees. We call them identical only if they have exactly the same shape and the same value at every matching position. Take a tree with root 1 and children 2 and 3. Compared with an exact copy, the answer is yes. Compared with one whose right child is 9 instead of 3, the answer is no. Let's write the check. We recurse down both trees together, keeping a matching node from each. If both nodes are empty at the same spot, that part matches, so we return true. If one is empty and the other is not, the shapes differ, so we return false. If both exist but their values differ, that is a mismatch, so false. Otherwise, the values agree here, and we require that the left subtrees match and the right subtrees match using the same function. Everything must line up for the whole answer to be true. If both nodes are empty, this spot matches, so we return true. If only one is empty, the shapes differ, so false. If both exist but their values are not equal, that is a mismatch, so false. Otherwise, we return true only when the left children match and the right children match, checked by the same function. Let's write the comparison and try it on a matching pair and a differing pair. First, the empty cases. Both empty means a match here. Only one empty means the shapes differ. If both nodes exist but their values differ, it is a mismatch right away. Otherwise, both left sides and both right sides must match too. Now, let's test it and hit run. There we go. The first two trees are identical, so we get true. The third has a 9 where the others have a 3. So the moment we reach that node, the values disagree and we get false. One comparison goes like this. If both nodes are empty, return true. If only one is empty or the values differ, return false. Otherwise, the values agree here, so we go on to check that the left subtrees match and the right subtrees match. In the worst case, we compare every matching pair of nodes once, so the time is order n, where n is the size of a tree. The extra space is a recursion stack as deep as the tree is tall, so order h. 3 reminders. First, check the empty cases before you read any value, otherwise you try to read from an empty node and crash. Second, matching values are not enough. The shapes must match as well, so a differently shaped tree is not identical. And third, both the left and the right subtrees must match, so join them with and never with or